Hello everyone, my name is Yeon-Woo. I am a climate scientist and researcher in the ATIL research group at MIT. As a member of the scientific team of Jamil Observatory CREWSnet, I worked with Professor ATIL to produce near-term climate change projection for Bangladesh. Our objective is to provide valuable information to inform vulnerable communities and policymakers. We aim to empower them so they may better prepare to deal with climate change impact. Our main focus is the region of southwest Bangladesh. This region is characterized by high exposure to hazard from climate changes, such as severe cyclone, extreme heat waves, sea level rise, and increasing water scarcity. The same region suffers from acute vulnerability. The combination of hazard and vulnerability maximizes the risk from climate change impact. To predict how future climate change would impact this area, we use state-of-the-art regional climate models developed at MIT. These models were developed by our research group over more than 30 years. MRCM is a dynamic model, like any global climate model. It is basically based on atmospheric carbon indications with some parameterizations for cloud physics, cumulus convection, planetary boundary layer, and radiation processes. We introduced significant model physics improvement based on research at MIT. MRCM has been tested extensively over most regions of the world. It shows significant scale in reproducing region-specific climate information over various domains, including over Bangladesh. In comparison to station observations, MICM shows significant scale to observed climate information in terms of temperature and precipitation over the various sub-regions of Bangladesh. For any regional climate simulation, a specific location is defined, and certain global climate models are used to prescribe conditions at the boundary of the domain. We conducted several MICM simulations constrained by boundary conditions from reanalysis observations and CIMI5 and CIMI6 models under different climate change scenarios. By applying MIT regional climate model, we aim to project future change in temperature and precipitation. Surface temperature over the country will continue to increase, becoming 1 to 2 degrees warmer by the mid-century under all emission scenario considered. Temperature in southwest Bangladesh is going to increase by 1.5 degrees Celsius under high emission scenario, and projected increase in temperature over the country will be accompanied by a significant precipitation decrease during the winter season. In addition to the projections of temperature and precipitation, we are also interested in how characteristics of tropical cyclones may change under climate change. Tropical cyclones mainly occur in pre-monsoon and post-monsoon season. However, we found that this seasonality in frequency of cyclone has been changing recently, especially in November. Also, we found significant changes in tracks of tropical cyclone in the recent period. More tropical cyclones are making landfall in the western part of the country. We wonder whether these changes are caused by climate change. So we plan to use MIT regional climate model to study changes in tropical cyclone under climate change in terms of frequency and their tracks. This model can reproduce tropical cyclone event very well. Here is an example for tropical cyclone Sidr in 2007 and cyclone Gorky in 1991. So the model has the ability to reproduce tropical cyclone event very well, especially intensity and tracks. So with this research, we aim to contribute toward a proactive, integrated, and evidence-based approach to climate change adaptation in Bangladesh.